Hello all listeners. Let's see this question of current electricity from Pathfinder. It's a paragraph question, MCQ 20 and 21. The question, there is a conducting balloon of initial radius A. It is charged to a potential V0 and is held at a large height above the Earth's surface. The purpose of keeping at large height above Earth's surface is to keep its charge distribution unaffected by Earth's charges, because Earth being a conductor. And then it is earthed by a resistor R, and there is a wall in the balloon. Through the wall some gas leaks, so the size of the balloon decreases, the radius decreases, the rate of decrease in the balloon is controlled in such a manner that the potential of the balloon is maintained, remain constant. And we have to also given that the charge only leaks through, charge does not leak into the atmosphere, the only flow of charge is through the resistor. And permittivity of the surrounding air is equal to epsilon naught, as it is always there. So we have to tell two things. Number one, the time rate at which r radius r of the balloon changes, and the second thing, how much is heat dissipated in the resistance until the radius of the balloon becomes half. Initial was a and final that becomes a by 2. So let's try to do this. Suppose at a future moment, at a general moment, suppose the charge of the balloon has become q and the radius has become r. The potential is maintained V0. So potential of the balloon is V0. So this point has also potential V0. And this is grounded. So its potential is 0. So there is a potential difference. So current will flow from balloon to ground through that resistor, and suppose that current is I. And this would be definitely higher and lower. So at the shown moment, if I write the potential of the balloon, that V0 is equal to K Q by R. So R will become K Q by V0. So rate of change of radius with respect to time dr by dt is equal to K by V0 into dq by dt. What is dq by dt? As r decreases, q decreases, so this charge decreases. So the decreased charge, the charge decreases, and that charge goes to the resistor. So there is a current. So I can write current in the resistor as a I is equal to minus dq by dt, because charge is decreasing. So this thing I can write it here, dr by dt is equal to k by v0. dq by dt is minus I, so I will write minus I here. And this equation I'll use in the second part. So dr by dt is equal to minus k by v0 and minus k by v0. I from the Ohm's law, you can write simply v0 by r. So into v0 by r, and this v0 will get cancelled. So finally you will get dr by dt is equal to minus k by r, and that will be minus of 1 upon 4 pi epsilon naught r, which is option B. Now, how much heat is dissipated in the resistance R until radius of the balloon becomes half? So at a general time, Q charge has become Q, radius has become R. So this is a very good question. That's why Pathfinder is good. It tests a very fundamental understanding. Potential is maintained at V0, and this is 0. Current I goes here. So one can think of, let's try to do one way, like I can write the energy of the conducting balloon, initial energy, final energy, and then the deficit of that energy will go to the resistor, that will appear as a heat. But there will be problem, because the radius is decreasing, so it's kind of a radiating charge. So it will radiate energy. So other than the self energy, some energy will be radiated into the atmosphere, because the size is shrinking. So I'll approach a fundamental way. I'll approach this problem in a very fundamental way. So suppose I had got this expression dr by dt is equal to minus k by v naught into I. So I'll use that thing. Dr by dt is equal to minus k by v naught into I. So I is equal to minus v naught by k into dr by dt. The heat developed, the power dissipated in the resistor at any moment. I can write I square R, I can write V square by R, but the better thing would be for me to use V naught into I. V naught is maintained and the current I flows, the power dissipated is V naught into I. Because I've got I as a function of R, so this I can put it here, so that will be minus V naught square by K into dr by dt, and the power dissipated, can write rate of dissipation of heat dH by dt minus V naught square by K into dr by dt. So this dt dt will get cancelled, so we can write dH is equal to minus V naught square by K into dr. Just integrate it. So total heat dissipated is equal to minus V naught square by K dr, and this R goes from A to A by 2. So that will be simply V naught square by K into A by 2, and put the value of K, we will get 2 pi epsilon naught A V naught square. If I use the other way, just I explain that, if I think that the heat dissipation is the deficit of the energy of the self energy of the charge balloon, I will get different answer, because in that case some of the heat also goes to, some of the heat is radiated by that charge because it is shrinking. So this is the answer, and let me check the option, and that is actually option B. Thank you. Option C.